35,000 decisions. That's the average number a human makes in a single day. What to eat for breakfast, when to leave for work, which route to take, what to buy, what to watch, which email to answer first. You think you made them. You weighed the options, considered the alternatives, and chose. You didn't. Most of those decisions were made for you by systems you've never seen, using data you didn't know was being collected, following rules you never agreed to. The choice you thought you made? It was pre-selected, optimized, decided before you knew there was a decision to make. Here are 10 invisible systems controlling your daily decisions while you think you're in control. You're booking a flight. You search Tuesday morning. The price is $289. You close the tab, think about it, come back 12 minutes later. Same flight, same date, same seat, $347. What changed? Nothing you can see. Everything the system can see. Before dynamic pricing, the problem was simple. A business set a price, and everyone paid it. But that left money on the table. Someone willing to pay $400 was paying $289. Someone who could only afford $250 wasn't buying at all. Dynamic pricing solves this by making price a variable, not a constant. Every customer sees a different number based on what the system thinks they'll pay. It follows 3 rules. Rule 1, willingness to pay detection. The algorithm analyzes 40-plus variables about you in real time. Your device type, your location, your browsing history, how many times you've searched for this item, how fast you're scrolling, whether you're on Wi-Fi or cellular data. All of it feeds into a predictive model that estimates your maximum willingness to pay. In 2012, Orbitz discovered that users on Mac computers spent 30% more on hotels than PC users. The algorithm adjusted. Mac users started seeing more expensive hotels listed first and higher prices on the same rooms. Not because the rooms were different, because the customers were. Rule 2, inventory velocity optimization. The system doesn't just look at you. It looks at how fast the product is selling. An airline seat selling slowly gets cheaper to attract buyers. A seat selling quickly gets more expensive to maximize revenue before it's gone. The price updates every few minutes based on real-time demand. That flight you were looking at? 15 other people searched for it in the last hour. The algorithm saw the demand spike and raised the price. Rule 3, competitive parity enforcement. The system monitors competitor prices in real time. If a rival drops their price, the algorithm adjusts to match or undercut. If competitors raise prices, it raises yours too. This happens automatically thousands of times per day with no human involvement. All of this is sustained by massive computational infrastructure. Amazon changes prices 2.5 million times per day. That's 29 price adjustments per second. Uber's surge pricing recalculates every few minutes across millions of active users. The systems never sleep. And here's what people get wrong about dynamic pricing. They think it's about fairness. It's not. It's about extraction. The algorithm doesn't ask what the product is worth. It asks what you're willing to pay. And it's designed to find the exact highest number you'll accept before you walk away. That $347 flight, it wasn't $347 because that's what it costs. It was $347 because the algorithm calculated that you'd pay it. You open Google Maps. Type your destination. The app shows 3 routes. Blue route, 22 minutes. You tap it. You're on your way. But here's what you didn't see. That route wasn't chosen to get you there fastest. It was chosen to keep the entire traffic system from collapsing. Before real-time routing, traffic was chaos. A million drivers making independent decisions about which road to take, all simultaneously creating bottlenecks nobody could predict. Navigation apps solve this through centralized optimization. But the optimization isn't for you. It's for everyone. The system follows 3 rules. Rule 1, system-wide efficiency over individual speed. Google Maps doesn't optimize your route. It optimizes all routes simultaneously. If sending you down Highway 1 saves you 3 minutes, but creates a jam that costs 50 other drivers 2 minutes each, the system sacrifices you. The math favors the many, not the one. You take the longer route. The system saves 97 total minutes across all drivers. You lose 3. The system wins. Rule 2. Predictive load balancing. The algorithm doesn't just react to current traffic. It predicts future traffic based on how many people are being routed to each road. If too many drivers are heading toward the same highway entrance, it starts diverting new navigators to alternative routes before the congestion even forms. You're not avoiding traffic. You're being redistributed to prevent traffic. Rule 3. Strategic misdirection. Sometimes the algorithm intentionally routes you on a slower path. In 2019, researchers at UC Berkeley discovered that Waze regularly sends drivers on routes 8 to 12% longer than necessary. Why? To prevent everyone from converging on the genuinely fastest route, which would immediately stop being fast. The system lies to you to protect itself. In one documented case, Waze diverted 15,000 drivers through residential neighborhoods to avoid a highway backup. The highway jam would have lasted 40 minutes. Instead, 15,000 cars flooded quiet streets, creating a different kind of chaos. The system optimized, just not for the residents who didn't consent to becoming a highway alternative. Here's the strange part. You can't opt out. If you ignore the suggested route and choose your own, the algorithm recalculates. It assumes other drivers will also ignore suggestions, adjust for the rebellion, and routes everyone else accordingly. Your independence becomes another variable in the system's optimization. Next time Google Maps suggests a route that feels wrong, you'll know it's not wrong for the system. It's just wrong for you. You open YouTube, scroll past 3 videos, click the 4th, watch for 8 minutes. When it ends, another video autoplays. You watch that one too, then another. 2 hours later, you've watched 11 videos. You think you chose them. You didn't. The algorithm chose them before you opened the app. Before recommendation algorithms, the problem was scale. YouTube receives 500 hours of video uploads every minute. 30,000 hours per hour. You can't browse that. You need curation. But curation has a goal. And the goal isn't to show you what you want. It's to keep you watching. The system follows 3 rules. Rule 1. Maximize session duration, not satisfaction. The algorithm doesn't optimize for videos you'll enjoy. It optimizes for videos that keep you on the platform longest. Sometimes those overlap. Often they don't. Research from 2018 found that YouTube's algorithm systematically recommends videos that are slightly more extreme than what you just watched. Not because extreme content is better, because it's more engaging. Engagement means longer sessions. Longer sessions mean more ads. You watched a video about fitness. The algorithm recommends a video about extreme diets. You watch that. Next up, a video questioning mainstream nutrition science. You didn't ask for conspiracy theories, but conspiracy theories keep you watching. Rule 2. Engagement probability scoring. Before you see a thumbnail, the algorithm has already calculated the probability you'll click it. The calculation uses 80 billion previous user interactions. It knows that you click videos with certain keywords in the title, certain colors in the thumbnail, certain video lengths, certain upload times. It knows you'll click before you know you'll click. Rule 3. Dopamine loop architecture. Each video is chosen to increase the probability you'll watch the next one. The algorithm builds a sequence, a pathway through content designed to keep you moving forward. The end of one video triggers a psychological need that the next video promises to fulfill. But that video creates a new need, and the cycle continues. This is sustained by infrastructure most users never think about. YouTube's recommendation system processes data from 2 billion logged-in users every month. Every click, every pause, every rewind, every abandonment feeds the model. The result? 70% of watch time on YouTube comes from recommendations. You're not exploring. You're following a path the algorithm laid out. And here's what most people get wrong. They think the algorithm is neutral, that it's just showing them what they like. It's not. It's showing you what keeps you watching. Those aren't always the same thing. You decided to watch 11 videos. No, you participated in 11 decisions. The system made them. You just click play. You open Uber Eats. You're hungry. You scroll through restaurants. The third one looks good. You order. Simple, right? But here's what you didn't see. That restaurant wasn't third because it's the third best option. It was third because it paid to be third. Before delivery apps, restaurant discovery was simple. You walked down the street, saw what was open, chose based on what you could see. Limited options, limited manipulation. Delivery apps changed that. Now, there are 300,000 restaurants competing for your attention, and the app gets to decide which ones you see and in what order. The system follows 3 rules. Rule 1, paid placement priority. Restaurants can pay for higher positions in search results, not explicitly as ads, as promoted or featured placements that look like organic results. A restaurant with a 3.5-star rating appears in position 2. A restaurant with 4.8 stars appears in position 12. Why? Position 2 paid for the spot. Studies show 80% of orders go to the top 5 results. If you're not in the top 5, you might as well not exist. Restaurants know this, so they pay. Rule 2, commission optimization. Delivery apps take a percentage of every order, usually 15 to 30%. But that percentage is negotiable. Restaurants that agree to higher commissions get better placement. The algorithm prioritizes partners that make the platform more money. Your search results aren't ranked by quality. They're ranked by profitability. For the app, not for you. Rule 3, relevant scoring based on retention. The algorithm tracks what keeps users on the platform. If you usually order from restaurants with certain cuisines, price ranges, or delivery times, it shows you more of those. Not because they're objectively good, because they match patterns that predict you'll order again. The app isn't helping you discover food. It's keeping you inside its ecosystem. In one documented case from 2021, a restaurant owner discovered that lowering their menu prices actually decreased their orders. Why? The algorithm interpreted lower prices as lower quality and dropped their ranking. They raised prices back, paid for promoted placement, and orders tripled. The customer never saw the restaurant before it paid to be visible. Here's the part that surprised me. The restaurant you ordered from might not have the food you want. In many cities, ghost kitchens operate multiple restaurant brands from the same physical location. Different names, different menus, different branding. But the same kitchen, the same ingredients, sometimes even the same dishes with different descriptions. The system creates the illusion of choice. You think you're choosing between 30 restaurants. You're actually choosing between 8 kitchens operating 30 brands. You didn't choose that restaurant. The algorithm chose it, the restaurant paid to be chosen, and you click confirm. You spent 4 hours on your resume, tailored it to the job description, highlighted relevant experience, wrote a compelling cover letter, hit submit. 2 days later, thank you for your application. Unfortunately, we've decided to move forward with other candidates. You assume a hiring manager read your resume and decided you weren't a fit. Nobody read your resume. A robot rejected you in 6 seconds. Before Applicant Tracking Systems, the problem was volume. A Fortune 500 company posts a job. They get 250 applications. Reading each resume for 5 minutes equals 21 hours. Multiply that by 100 job postings. Nobody has that time. ATS solved this by automating rejection. But automation requires rules, and rules create bias. The system follows 3 rules. Rule 1, keyword density scoring. Your resume is scanned for specific keywords from the job description. The system counts how many times each keyword appears and in what context. It assigns a score from 0 to 100. If you score below the threshold, usually 75, you're auto-rejected. No human review. The algorithm doesn't understand experience. It counts words. You have 15 years managing teams, but you use the word manage instead of led. The job description said led. Your score drops. You're out. Rule 2, auto-rejection threshold. 99% of Fortune 500 companies use ATS. 75% of resumes are rejected before a human sees them. The average processing time is 5 to 6 seconds per resume. The algorithm looks for disqualifying factors, employment gaps, lack of specific degree, missing keywords, incompatible file format. In one documented case, a candidate with 15 years of software engineering experience was auto-rejected because he submitted his resume as a PDF with custom fonts. The ATS couldn't parse the formatting. It registered as a blank document. Score: 0, rejected. Rule 3, experience gap penalty. Any unexplained gap in employment history triggers a penalty. 6 months between jobs? Your score drops. A year? You're likely auto-rejected. The system doesn't care why. Medical leave, parental leave, caring for family, traveling, starting a business. None of that matters. Gap equals penalty. This creates perverse incentives. Candidates start lying, listing unemployment as freelance consulting or extending previous job end dates. The algorithm can't verify. It just scans. Here's where it gets worse. The algorithms learn from historical data, and historical data is biased. In 2018, Amazon had to shut down its recruiting AI after discovering it systematically downgraded resumes that included the word women's, as in women's chess club captain. Why? The AI was trained on 10 years of Amazon's hiring data, which was predominantly male in technical roles. The algorithm learned that male candidates were more likely to be hired, so it started penalizing signals associated with women. Amazon caught it. How many companies haven't? You weren't rejected because you lacked qualifications. You were rejected because an algorithm trained on biased data, using arbitrary keyword matching, decided in 6 seconds that you weren't worth a human's time. Your credit score is 732. That number determines whether you can buy a house, lease a car, get approved for a credit card, sometimes even get hired for a job. But nobody will tell you exactly how it's calculated. The formula is proprietary, secret, and it controls your financial life. Before credit scoring, the problem was consistency. Banks made lending decisions based on personal judgment. Loan officers met applicants, assessed risk subjectively. 2 identical applicants could get different decisions from different banks, different officers, different moods. FICO scoring standardized this. One number, calculated by algorithm, applied uniformly. But standardization doesn't mean fairness. It means consistent application of potentially unfair rules. The system follows 3 main rules. Rule 1. Payment history weighs 35%. One late payment could drop your score by 100 points. That penalty lasts for 7 years. Doesn't matter if you were laid off, hospitalized, or forgot because you moved and didn't update your address. Late equals penalty. For 7 years. A single mistake compounds. Lower score equals higher interest rates on existing debt equals harder to pay on time equals more late payments equals lower score. The system punishes you, then makes it harder to recover. Rule 2. Credit utilization cliff. This is the percentage of your available credit you're using. Using 30% of your total credit limit, your score is fine. Using 31%, penalty. The algorithm treats 30% and 31% as categorically different, even though they're effectively identical. Worse, paying off a credit card entirely can hurt your score. Why? Because it reduces your total available credit, which can push your utilization percentage higher on remaining cards. You did the responsible thing. The algorithm penalized you. Rule 3. Hard inquiry cascade. When you apply for credit, the lender checks your score. That's a hard inquiry. Each inquiry drops your score by 3 to 5 points. The drop lasts for 12 months. Here's the cascade. You apply for a mortgage. Your score drops 5 points. Now you're below the threshold for the best rate. So you apply to another lender. Another 5 points. Now you're the next tier down. You apply to a third lender. Another drop. You're trying to shop for the best rate, and the system is punishing you for it. The infrastructure behind this is massive. FICO processes data from 220 million credit files. Those files are updated 2 billion times per month. Every payment, every inquiry, every balance change feeds the algorithm. But here's what most people don't realize. Paying off debt doesn't always help. In some cases, it hurts. If you have a car loan and pay it off completely, your score might drop. Why? Because you now have fewer types of credit. The algorithm wants to see that you can manage multiple kinds of debt simultaneously. Having only credit cards is worse than having credit cards plus a car loan plus a mortgage. You eliminated debt. The algorithm sees it as reducing diversity, and this affects everything. A person with a 720 credit score pays, on average, 0.5% more in mortgage interest than someone with a 740 score. On a $300,000 mortgage over 30 years, that's $52,000 in additional interest. A 20-point difference. That's 4 hard inquiries. That's 1 late payment that happened 6 years ago. The system remembers everything, forgives slowly, and uses a formula you're not allowed to see to make decisions that control whether you can buy a home. You didn't get rejected for that loan because you're financially irresponsible. You got rejected because an algorithm applied secret rules to data you can't correct and decided your 732 wasn't good enough. Your doctor examines you, runs tests, makes a diagnosis, writes a prescription for a specific medication that she believes is best for your condition. You take the prescription to the pharmacy. The pharmacist types it into the system. The system denies it, suggests an alternative. Your doctor didn't approve the alternative, but you're getting it anyway. Welcome to pharmacy benefit managers, the invisible middlemen who decide what medicine you actually receive. Before PBMs, the system was simple. Doctor prescribes. Pharmacy fills. Insurance pays. But that left no room for cost optimization. Different patients getting different medications at different prices with no centralized control. PBMs solve this by inserting themselves between doctors, pharmacies, and insurance companies. They negotiate drug prices, create formularies, and decide which medications are preferred. And they make those decisions using algorithms you never see, based on contracts you didn't agree to. The system follows 3 rules. Rule 1. Formulary tier enforcement. Every PBM maintains a formulary, a list of approved medications organized into tiers. Tier 1. Preferred, cheap. Tier 2. Accepted, moderate cost. Tier 3. Non-preferred, expensive. Tier 4. Not covered. Your doctor prescribes a Tier 3 medication. The PBM's algorithm automatically suggests a Tier 1 alternative. The pharmacist calls your doctor to request substitution. Your doctor, overwhelmed with patients, often just approves it. You get the cheaper medication whether it's clinically equivalent or not. Rule 2. Prior authorization gatekeeping. For expensive medications, the PBM requires prior authorization. Your doctor must submit paperwork proving the medication is medically necessary. The PBM's algorithm reviews the submission. If it doesn't meet predetermined criteria, it's denied. The criteria are based on cost, not just clinical necessity. The algorithm asks, is there a cheaper alternative? If yes, denial. Your doctor can appeal. The appeal takes 2 to 6 weeks. Meanwhile, you're not getting treatment. Rule 3. Therapeutic substitution. The PBM can substitute your prescribed medication with a different drug in the same therapeutic class without consulting your doctor. Your doctor prescribes insulin brand X. The PBM has a contract with insulin brand Y. The algorithm automatically approves Y, denies X. The pharmacy dispenses Y. You don't even know a substitution occurred. 3 PBMs control 80% of prescriptions in the United States. CVS Caremark, Express Scripts, and OptumRx. They process over 4 billion prescriptions per year. And here's where it gets dark. In 2020, a woman with stage 3 breast cancer had her oncologist prescribe a specific chemotherapy drug. The PBM denied it, citing lack of medical necessity. The oncologist, a specialist with 20 years of experience, appealed. The appeal was reviewed not by another oncologist, but by an algorithm checking boxes against predetermined criteria. Denial upheld. The oncologist prescribed an alternative. The PBM approved it. The patient started treatment 6 weeks later than planned. She died 8 months later. Her oncologist testified that the delay likely contributed to the outcome. The PBM released a statement saying they followed standard protocols. Here's what people get wrong about PBMs. They think PBMs are negotiating lower drug prices to help patients. They're not. They're negotiating rebates from drug manufacturers in exchange for formulary placement. Those rebates don't go to patients. They go to the PBM and the insurance company. You pay full price. The PBM gets a rebate. The drug stays expensive. Everyone profits except you. Your doctor didn't choose your medication. A contract between a PBM and a pharmaceutical company chose it. Your doctor just signed off on what the algorithm approved. You find the perfect apartment. Good location, reasonable price, available immediately. You fill out the application. Provide references. Submit pay stubs. Wait. 3 days later, we've decided to move forward with another applicant. You assume the landlord chose someone else. The landlord never saw your application. An algorithm rejected you before your name reached a human. Before tenant screening algorithms, the problem was subjectivity. Landlords made decisions based on gut feeling, personal bias, inconsistent criteria. Two identical applicants could get different outcomes based on nothing more than the landlord's mood. Screening algorithms standardized this. One score, calculated from data, applied uniformly. But standardization amplifies bias when the data itself is biased. The system follows 3 rules. Rule 1, criminal history penalty, including expunged records. The algorithm scans criminal databases. Any arrest, even without conviction, can lower your score. Charges that were dropped, cases that were expunged, juvenile records that are legally sealed. If it's in a database somewhere, the algorithm can see it. In many states, it's illegal for landlords to discriminate based on expunged records. But the algorithm doesn't discriminate. It just assigns a score. The score is lower if you have a record, expunged or not. The landlord never knows why. They just see. Applicant score June 2nd, 10. Next applicant score, 8.1/10. They choose the higher score. Rule 2, income to rent ratio hard coding. Most algorithms require that your gross monthly income be at least 3x the monthly rent. Some require 3.5x or even 4x. This is hard-coded. No exceptions. You make $4,500 per month. The rent is $1,500. That's exactly 3x. You're approved. The rent is $1,501. That's 2.99x. Rejected. $1 makes the difference. This disproportionately affects lower-income applicants. Someone making $6,000 per month applying for a $1,500 apartment equals easy approval. Someone making $4,000 per month applying for a $1,200 apartment equals denied for insufficient income. Both are paying 25% of income. The algorithm treats them differently. Rule 3, zip code risk scoring. The algorithm analyzes your previous addresses. It assigns risk scores to zip codes based on crime rates, eviction rates, and average income. If you previously lived in a high-risk zip code, your score drops. This perpetuates segregation. You grew up in a low-income neighborhood. You get a good job. You're trying to move to a better area. The algorithm sees your old address and flags you as high risk. You're being punished for where you came from. 2 companies dominate tenant screening, CoreLogic and RentGrow. They process over 100 million screenings per year. In one documented case, a woman with a credit score of 780, stable employment, and no criminal record was denied an apartment. She requested her screening report. The algorithm had flagged her as high risk because her name was similar to someone else with an eviction history. Similar name, different person, different birth date, different social security number. She filed a dispute. The process took 3 months. By the time it was resolved, the apartment was rented to someone else. And here's the part that makes it worse. You often don't know you've been screened by an algorithm. The landlord receives a score, a recommendation. They're not required to tell you how the decision was made. You just get rejected. No explanation. No recourse. You weren't rejected because the landlord didn't like you. You were rejected because an algorithm gave you a score of 6.2 based on data you can't see, using criteria you don't know, with errors you can't correct. You open your phone, check the news, scroll through headlines, read 3 articles, close the app. You think you're informed about what's happening in the world. You're not. You're informed about what the algorithm decided you should see. Before news curation algorithms, the problem was information overload. 2.5 million news articles are published every day. Nobody can read that. You need filtering. But filtering has consequences. And the consequences depend on who does the filtering and why. The system follows 3 rules. Rule 1. Engagement maximization over importance. The algorithm doesn't prioritize the most important news. It prioritizes the news you're most likely to click on. Those aren't always the same. A major policy change affecting millions of people gets ranked below a celebrity scandal because the algorithm predicts you're more likely to click the scandal. You never see the policy change. Not because it's not important, because it doesn't maximize your engagement. Rule 2. Confirmation bias reinforcement. The algorithm tracks what you've clicked on before. If you've clicked on articles with certain political leanings, it shows you more articles with those leanings. If you've clicked on content that confirms your existing beliefs, it shows you more confirming content. This isn't a conspiracy. It's optimization. The algorithm learned that people engage more with content that confirms what they already believe. So it shows you more of that. You're not getting news. You're getting validation. Rule 3. Geographic and demographic personalization. The algorithm knows your location, age, gender, income bracket, browsing history. It uses all of it to customize what news you see. 2 people in the same city, same age, same day will see completely different front pages, different headlines, different stories, different priorities. They're not reading different sources. They're reading the same source, but the algorithm is showing them different realities. Google News processes 5 billion page views per day. Facebook's news feed serves content to 2.9 billion users. Apple News has 125 million active users. All of them use algorithmic curation. In 2020, researchers at Northeastern University conducted an experiment. They created 100 fake user profiles with different demographic data and browsing histories. They tracked what news Google News showed each profile over 30 days. The results: profiles labeled as conservative saw 74% of their news from conservative sources. Profiles labeled as liberal saw 71% from liberal sources. Profiles labeled as moderate saw a mix, but the mix was still skewed based on browsing history. The algorithm wasn't trying to create echo chambers. It was trying to maximize engagement. But the result was the same: fragmented realities. Here's what surprised me. The algorithm doesn't just filter what you see. It filters what you think is happening. During the 2024 election, 2 Americans in the same state checked the news on the same morning. One saw headlines about economic policy. The other saw headlines about immigration. Both were on Google News. Both were reading the news. But they came away with completely different understandings of what was important that day. The algorithm didn't lie to either of them. It just showed them different truths. You're not reading the news. You're reading your version of the news, filtered by what you've clicked before, what people like you tend to click, and what keeps you coming back. And the more you read, the more the algorithm learns, the more personalized it becomes, the narrower your information bubble gets. You don't decide what news is important. The algorithm decides what news you'll think is important. Correct. You book a flight. You pay extra to select your seat. 12A window. Exit row. Extra legroom. You check in. Your boarding pass says 34B. Middle seat. Back of the plane. No explanation. You didn't get bumped. You got optimized. Before yield management systems, airlines had a simple problem: how to maximize revenue on every flight. Sell every seat at the highest possible price while minimizing empty seats. Yield management solved this with algorithmic pricing and seat assignment. But the algorithm's goal isn't your comfort. It's the airline's profit. The system follows 3 rules. Rule 1. Overbooking optimization. Airlines know that 5 to 10% of passengers don't show up for their flights. So they sell 105 seats on a plane with 100 seats. Usually it works out. Sometimes it doesn't. When everyone shows up, the algorithm decides who gets bumped. It's not random. It's calculated. The algorithm looks at ticket price, frequent flyer status, check-in time, connection status, fare class, whether you're traveling alone or with others. It assigns each passenger a priority score. Lowest score gets bumped. In 2017, United Flight 3411 was overbooked. The algorithm selected 4 passengers to remove. One of them was Dr. David Dow. He refused. Security dragged him off the plane. The incident went viral. United apologized, but the algorithm was working as designed. Dr. Dow had the lowest priority score. The system chose correctly. The execution was brutal, but the selection was algorithmic. Rule 2. Upgrade priority scoring. When a flight has empty first class or business class seats, the algorithm decides who gets upgraded. This also isn't random. It's a score based on 12+ variables: frequent flyer status, ticket price, fare class, credit card status, lifetime spending with the airline, even your social media influence. The person in 34B gets upgraded. You stay in 34A. You pay the same price. You checked in at the same time. The difference? They have the airline's credit card. You don't. The algorithm chose them. Rule 3. Involuntary seat reassignment. Airlines overbook premium seats just like they overbook flights. You paid $80 to select seat 12A, but the airline sold that seat to 3 different people. All 3 check in. 2 of you are getting moved. The algorithm decides who keeps the seat and who gets downgraded. It's based on fare class and status. You bought a basic economy ticket and paid extra for the seat. Someone else bought a full fare economy ticket. The algorithm prioritizes them. You get moved to 34B. Your $80? Refunded. Your preference? Ignored. The infrastructure behind this is massive. Airlines process 44,000 flights per day globally. Each flight has 150 to 300 passengers. Each passenger has dozens of variables. The system optimizes 2,000+ variables per flight in real time. And here's where it gets strange. The algorithm sometimes makes decisions that seem irrational. In 2019, a family of 4 paid to select 4 seats together. At check-in, they were separated. 2 adults in row 8. 2 children, ages 6 and 8, in row 28. The parents asked to be moved together. The gate agent said the system wouldn't allow it. Other passengers had to volunteer to switch. Why did the algorithm separate them? Because the system optimized for overall load balancing, distributing weight throughout the aircraft. For people in the same row, created a slight imbalance. The algorithm moved the lighter passengers, the children, to the back. The system prioritized aircraft weight distribution over keeping a family together. You paid for seat 12A. The algorithm assigned you 34B. Not because you did anything wrong, because someone else's variable scored higher, and the system's goal is optimization, not satisfaction. Here's what you probably didn't realize. These 10 systems don't work in isolation. They're connected. They share data. They influence each other. Your credit score affects the car insurance prices you see. That's System 6 feeding into System 1. Your browsing history influences the salary ranges shown on job postings. System 3 affects System 5. Your zip code determines which apartments are shown to you, which determines where you live, which determines your commute, which determines the route optimization system's decisions about your time. System 8 feeds into System 2. One algorithm's output becomes another algorithm's input. Your content consumption history affects which news stories you see. Your food delivery patterns influence the pricing you get. Your travel history affects credit decisions, because credit bureaus now incorporate alternative data like utility payments and rental history, and some include travel patterns as stability indicators. You're not making individual decisions in isolation. You're navigating a web of pre-made decisions that compound, interact, and constrain each other. And somewhere in the middle of that web, you exist, thinking you're choosing. The systems don't coordinate intentionally. There's no central control, but they all optimize for the same thing, extracting maximum value from your behavior. Maximum engagement, maximum revenue, maximum efficiency. And when every system is optimizing simultaneously, you get emergent effects that nobody designed but everybody experiences. You can't get the apartment because your credit score is too low. Your credit score is low because you had a medical emergency. You had medical bills because the PBM denied your preferred medication and the alternative was less effective. You needed that apartment because your commute is 90 minutes each way. Your commute is 90 minutes because the routing algorithm optimized for system efficiency, not your time. It's not one system controlling your life. It's 10 systems interacting, compounding, creating a maze of pre-made decisions that you navigate daily while maintaining the illusion of choice. So, 35,000 decisions today. You controlled maybe 7,000 of them. What to say in a conversation. Whether to respond to that text. How much salt to add to your dinner. Small, personal, unoptimized choices. The other 28,000? The route you drove was chosen to optimize traffic for everyone else. The price you paid was calculated to extract your maximum willingness to pay. The content you consumed was selected to maximize your session duration. The food you ordered was ranked by who paid for placement. The job you applied for was rejected by a robot before a human saw your name. Your credit score was calculated by a secret formula. The medicine you take was chosen by an algorithm that overruled your doctor. The apartment you can't rent rejected you based on where you used to live. The news you read was filtered to match your existing beliefs. The seat you sit in was assigned to optimize the airline's profit. These aren't conspiracies. They're not evil. They're not even secret. They're just invisible. Systems optimizing billions of decisions because humans can't process that scale. And the result is that most of your daily autonomy is an illusion. You participate in decisions. Systems make them. Next time you decide something, ask yourself, did I choose this? Or did a system I can't see choose it for me? And I just click confirm. Because the answer for most of your 35,000 daily decisions is the second one. This is the invisible architecture of modern life. The systems quietly controlling your decisions while you think you're in control. And now you see them.